So, let's start this lesson by opening Unity Hub and create a new 3D project called E4 Components and Script Anatomy. In the last lesson, we vaguely grasped the structure of a Unity's project, and now it's time to go a little bit deeper into some of the technical aspects of it. In this lesson, I'm talking specifically about the scripting in Unity and the relation with the game objects and other components. As you already know, Unity uses the C# language for scripting. I will do some practical examples and explain the concepts as we go along with the structure of the script. To do that, we need to add some objects to the scene to allow us to work on top of real components. Start by changing the layout to My Layout. Right-click on the hierarchy and select 3D Object, Cube. Zoom a little bit, and in the Game panel, set aspect to 16:9. Return to the scene, select the main camera game object in the hierarchy panel, and go to the Game Object menu and select Align with View. This will put the game camera in the same position of the editor's camera. If you go to the game panel, you can see the same point of view as in the scene panel. To finish this prep, let's just give the cube a different color. On the project panel, create a folder called Materials inside the Assets folder. Right-click on the Materials folder and select Create Material. Call it red or any other color and press Enter. In the inspector, change the material's albedo to the selected color. Now you can drag the material to the cube game object in the scene and we are ready to go. Create a script folder on Assets. Inside the script folder, create a C# script and press Enter. Now rename the script to Cube Controller and add it to the cube. This is the first problem you may encounter when creating a script. Unity doesn't allow you to add the script and the error says can't add script component CubeController because the script class cannot be found. Make sure that there are no compile errors and that the file name and class name match. Well, the problem and the solution is right there. Make sure that the file name and the class name match. When a new script is created, Unity will give the file name to the class inside. When you decide on changing the script's name, Unity will not update the class name inside, and because they don't match, the script can't be used. The solution is very simple. Open the script and change the class name to be equal to the script's name. Save and return to Unity. Now everything will work fine. Open the Cube Controller's script in Visual Studio and look at the structure. At the top you see the namespaces. Right below you have the class. Inside the class you'll find two methods, the start method and the update method. Notice two details. The class and the methods have some properties, a name, eventually some arguments, but in the next line they start with the left curly bracket and eventually end in a right curly bracket. If these classes and methods were boxes, this defines what is inside or outside. In this case, the start and update are inside the class. The other detail is that dark green sentence that is written in plain English, and somehow the compiler does not find any errors in that code. That is because of the double slash at the beginning. That is the way we set a comment, and the compiler will ignore it. Namespaces are like containers for classes or code bundles that you can use in your code. For example, the MonoBehavior base class is inside the Unity Engine namespace. These namespaces help you organize your code and, in a more advanced way, allows you to compile faster. But that will not be a problem for these lessons. You can create your own namespaces with code you use a lot in your games, but those techniques and optimizations are not necessary for a beginner to understand the game engine. The class is where the things happen. This specifically is a public class, meaning it is available to other classes to access it. It has a unique name and inherits from the monobehavior base class, meaning all methods inside the monobehavior are now accessible and can be used in this script. Monobehavior is a base class provided by the Unity engine, and it allows, for example, to add the script to the game object in the Unity editor. Without it, you will not be allowed to add the script to the object. You will often see methods being called functions and vice versa. It's technically the same thing, so because C#, this is a method. This start method comes from the Unity engine and runs once before the first frame. Normally is used to set up the initial values of a script. On the other hand, this update method will run once every frame. Here is where the game happens, and if you have a powerful machine, the code inside can happen 300 times per second, or if you have a toaster, maybe 40. It is totally dependent on the computer capabilities, what can bring timing problems, but more on that later. Let's create a new method to analyze its structure. Private float adding numbers, open parenthesis, float x value, comma, float y value, close parenthesis, enter, open curly brackets, enter, return x value plus y value, semicolon. A method is composed by its access level, private or public, its return type, in this case a floating number, its unique name in its parent class, and some arguments, in this case 2 floating variables. The return type defines what the method will give back when it's called to run. Let's say print, open parenthesis, adding numbers, open parenthesis, 4, 7, close parenthesis for adding numbers, and close parenthesis for print, semicolon. If in the start method the printing function calls the method by giving it to numbers, the adding numbers method will calculate the sum of them and return the result. Return x value plus y value. But it's going to return to where? Well, in this case, to the print function's argument. The print function will write in the console whatever is inside the parentheses, but in this case it will not print the method as it's written there, but the result of the sum, because adding numbers will calculate the sum of 4 and 7 and return 11. The print function will only see 11, the result, the return value, and will only print that. This is one way for methods to communicate with each other and pass information to make your game characters interact, for example. If you save and run it, you can see exactly that in the console. Not all methods have a return type. In the start and update, for example, the return is void, meaning the method does not return any value of any kind. The code inside is just executed from top to bottom. Also, not all methods need arguments to work. Many times we see the empty parentheses, meaning that the method is initialized, but it's not expecting any value, and actually it's not even possible to inject any value through this way. Let's start our practical example with the variables. This base script does not have any variables. A variable is a space allocated in memory that you can use to read and write values in runtime. To create a new variable, you need to declare it, and to do so, you need to write the data type and a unique name for the entire scope. So, find some space in line 7 and type public float walking speed semicolon. Note that the first character of the name of the variable is always a lowercase letter, and then, if the name is composed of more than one word, we use a capital letter for two reasons. First, it's easier to read, and second, the inspector panel uses that capital letter to write the name of the variable in a human form. So, if you save and return to Unity, you can see that the variable has a normal spelling and is humanly readable. So, stick with this convention. A variable is declared or created by pointing to its access level, this case public, the data type, this case float, and the name. If you really need the variable to start with the default specific value, you can assign that in the variable's declaration by adding equals 500, for example. Every time you drag this script to an object, the default value of this variable will be 500, but it's not locked. You can always change it later. The scope for this variable is the entire class, because it was created in the beginning of the class. It is available to every method inside the class. For example, this xValue variable is only available to be used inside the adding numbers method because it was created inside it, and in this specific case as an argument, meaning it's not possible to use xValue in the update method, for example. The access level defines if the variable can be read or written from outside of the script. Let's say you have another script that controls the wind speed, and every time the wind is stronger, the wind controller will access this variable and change the number. You can only do that if the variable is public. You can set it private or just delete the access level. It will be private by default. If a variable is private, it will not appear in the inspector, but there is a way to do that without exposing the variable to other scripts. So let's see these four cases. Comment public variable that appears in the inspector, private variable that is hidden from the inspector, private variable that appears in the inspector, and public variable that is hidden from inspector. The first two are the ones where you don't need to do anything special. A public variable will appear in the inspector and a private one will be hidden by default. But if you need to force a private variable to show in the inspector or a public one to be hidden, you need to add these attributes to the variable declaration. Open square brackets, serialize field, close square brackets, private float money equals 0 semicolon. Open square brackets, hide in inspector, close square brackets, public int lives equal 3 semicolon. The serialize field will allow the inspector to show the variable, and the hide in inspector will do the opposite. Save and return to Unity to see this happening. So why do you need any variable to show in the inspector? Well, because some scripts can really have dozens of variables, and many of them are just temporary data holders that don't need to be tuned. They are just working variables. Also, the intent of having the inspector is to facilitate teamwork. With this in mind, having access only to the variables that tune the gameplay, it's enough and keeps the inspector panels with the minimum needed controls. The data type of a variable will define which kind of data it can hold. An integer can't hold a word because it's expecting an integer number. For example, the number 8. So, how many types there are? Well, we have integers, float, double, booleans, characters, and structs as a value type, and classes as a reference type. A value type variable holds data by itself, and a reference type is an access to another class. In the next practical example, we will use some variables to look into them more deeply. Let's start with the integer and the float. An integer can hold a number without decimal places, like the number 8. Int power-ups equal 8, semicolon. On the other hand, a float variable will work with decimal places, even if the number entered does not have them. Float tilt angle equals 203, semicolon. Or float pitch angle equals 6.7 f, semicolon. The f character at the end is mandatory for a float number if you need to specify the decimal part. These two types are not directly compatible. Also, transforming a float into an integer will not round up the number. For example, if you have 5.7 and transform it directly to integer, you will get 5, not 6. To round up, you need to use some math functions. The double type is like a float but uses more memory. This means that you only need to use it if you have a number with a really long and detailed decimal part and you really need precision in your calculations. These take longer to process and can be an efficient problem if your game gets big enough. Normally, the float can handle any value you need to calculate in a normal and non-scientific game or simulation. Also, when giving a value to a double variable, you don't need the f character at the end. Double landing angle equals 6.7, semicolon. To compare them, let's divide all three variables and print the result. In the start method code, print open parenthesis, open quotation mark, this is a float, space, close quotation mark, space plus space. And now let's add the second part of this sentence, pitch angle divided by tilt angle, close parenthesis, semicolon. On the next line, print open parenthesis, open quotation marks, this is double, space, close quotation marks, plus landing angle divided by tilt angle, close parenthesis, semicolon. So, the float and the double variables have the same value but different resolutions. When we print them, the result will be different, not in terms of value, but in terms of detail. A Boolean is a variable that only uses one bit of memory because it only needs to store two values, false or true, so 0 or 1. A Boolean variable can be used to toggle functions or to test states in your game. As an example, we can trigger a calculation of damage when a specific variable is true. Open square brackets, serialize field, close square brackets, bool, walking on acid equal false, semicolon. We can use a variable like this to decrease the player's life a little bit, and by the name of the variable, I'm assuming you can imagine the situation. An if statement can be used to compare the variable's value and execute some code accordingly. Let's code an example. Serialize field float health equal 100. And now on the update method code this. If, open parenthesis, walking on acid is equal true, close parenthesis, enter open curly brackets, health equals health minus 0.01f semicolon. As a quick side note, if you need to test, you use two equal signs. If you need to tell, you use one. So, because we are asking about the variable's value, we use two equal signs. But down here, we are telling the computer the value of the variable. So in this case, we use only one. This is a very simple way of memorizing it. Back to our example. If you go to Unity and run the code, you can see in the inspector the health value unchanged. But if you make the Boolean variable go true, the if statement will run the code inside. If you change again to false, the if statement will stop working because the test is failing. Eventually, I will explore a bit deeper the if statement, but that is for another time. Char or characters type variables can hold only one character, like the letter A, number 7, or the enter key code. I will not use this type of variable in this series of lessons, so if you are interested in learning them, you should go on Google and search for it. Anyway, in the description I put a link to a good source. A struct is, let's say, a group of individual variables in one name. This is not the best technically correct way of expressing, but it is just a way to exemplify the concept to a beginner. In Unity, the most used structs you may encounter are vectors and quaternions. And where exactly can you find them? Well, in every game object. If you go to the inspector of any game object, you will find at the top a component called transform. This component is responsible for putting the game object in the world in a specific position, with a specific rotation, and with a specific scale. Well, if you look closely, the position variable does not have just one value. It has three: the x-axis, the y-axis, and the z-axis. The position variable is in fact a vector3 type of variable. A vector3 is a struct expecting three floats. As an example, let's code serialize field vector3 target position. This will declare a vector3 type of variable, but if we need to give it a value, we cannot do something like is equal to 456. You need to dump another vector3 on it. So let's code this. To add values to a vector3, you need to add equals new vector3 open parenthesis 4, 5, 6 close parenthesis semicolon. It's like copying a vector into another. You can also change only one axis by calling it individually and changing the number, but I think this only works for users' vectors. You can't do this to the transform position, for example. So to change the value of the x-axis, you do target position dot x equals 3. You call the variable dot the element you want to change. By the way, vectors are expecting floating numbers. So let's test. Here is the 4, play. Now there is a 3. But all this is just how to use a struct like the vector3. But if they are constructions with several individual values, the question is, how to make one? This is not as simple as an integer or a Boolean. First, we need to build, let's say, the body of the struct with the desired individual variables, and only after you are allowed to declare a variable of that type. We start by building the body of the struct, public struct raceCar, open curly brackets, and inside public float tank capacity, public float engine speed, public float car speed, public int gear count, public int current gear. Now that we have the body, we can declare the variable public raceCar BMW. In this case, making the struct and the variable public will not be enough to appear in the inspector. Unity does not serialize user structs unless you force that with an attribute. So add this before the struct's body creation. Open square brackets, system.serializable, close square brackets. Now we can see the struct variable in the inspector and we can set the values there. To use these values, you just need to call for the variable name dot element name. Print BMW dot tank capacity plus open quotation liters. Control save and play in Unity, and you get 60 liters. Here, almost every component can be the type. Imagine you need to read the position of another object. The best way is to access the other object's transform and get the numbers from there. To do that, you declare a reference to the component you need to read from. This case is the transform, so you can just serialize field, transform, other transform. So it's going to be configurable in the inspector, is expecting a transform, so the type is transform, and it's called other transform. Save and return to Unity. You can see you have a slightly different variable. It says none and it has a little menu. You can select an object from here or just drag one from the hierarchy panel. Let's duplicate the red material and change the color. Ctrl D, rename to blue, change color to blue. Now, create a sphere, scale it in the X only to around 3 and move it away from the cube. Now drag the blue material to it. Now you can select the cube and drag the sphere to the transform variable of the cube controller script. As you can see, the transform of the sphere is now the other transform variable, and you can access it to read or even to write data into the sphere's transform. In this case, I will copy the values from the cube's transform to the sphere transform. When you just write transform like this, you are referring to the self-transform, in this case the cube's transform. If you hit the play button, the sphere should go to the cube's location. So, this reference type of variables are not to hold data inside the script, but to access other variables in other scripts. If your other scripts have a public class and a public variable, you can also do this. Eventually, we will experience a real-world use of all of these examples if you think this is too much and too complicated. After all, we are only in our first real lesson. So let's recap everything by commenting every line of code in the script. Declaration of a Public variable that appears in the inspector, default behavior. Private variable that is hidden from the inspector, default behavior. Private variable that appears in the inspector by force. Public variable that is hidden from the inspector by force. Integer variable, just a number with no decimal point. Float variable with decimal point. Here will be 0, 203.0, so you don't need to write the .0. Float variable with decimal point. The F character makes the number a float, or else it is a double. Double variable, it's like the float but with more resolution. Boolean variable set to false. Float variable set to 100. A struct vector3 variable set to x4, y5, z6. Attribute to make the struct serializable by Unity and appear in the inspector. Creation of a struct variable. Individual elements inside our struct variable's body. A float variable. Another float variable. Yet another float variable. Now an integer variable and a last integer variable. By the way, the order in the inspector will be the same as here. Declaration of a race car type variable. Declaration of a transform type variable. The start method. It belongs to Unity. This will run before the first frame updates. Changing just one element of a struct variable, in this case the x-axis of a vector3. Write in the console the returned value of our method. Writing in the console the result of a division of two numbers, but a float result because the variable is a float, a double result because the variable is a double. And note how many numbers appear in the console. Doubles are bigger and more expensive. Write in the console just one element of our created struct, in this case the tank capacity element of the race car type. Set the other object's transform position with the same values of self's transform position. The update method, this also belongs to Unity. This will run once per frame during play. Powerful computers run this more times per second. Check if the Boolean variable is true. If it is, the code inside the curly brackets will run. The health variable value will increase by 0.01 every frame of the game. Creation of a private method that expects two float numbers and return another float number. Returns the sum of the inputted numbers. So, this lesson grasps the most common simple cases of using variables. There are many other details that are easier to explain with a real-world case. To do that, we really need to make a game and apply these concepts. In the next lesson, I'm going to start making a prototype of a game. I will talk a bit about the game structures and how a level should run. After we have those plans made, we can start by implement the necessary features to make it happen. A lot of stuff will be necessary, but with the plan, we can easily break down the small elements and work on them one by one, and eventually the game will start to take shape. Note also that I will start to simplify my speech. I'm assuming you already understand the syntax, or if you don't, you just copy it from the video and you will make sure to type the things correctly even if I don't talk about all the tiny details like the parentheses and semicolons, etc. Eventually, I will do it if it's a new thing, but only once. If you really want to learn this, you really need to code by yourself. I hope you enjoyed this lesson and learned anything new. For today is done, so I'm hoping to have you in the next one. See you!